Hi, and welcome back to Kira Tech Hub. My name is Paulina Mwakira, and this video is actually a continuation of a series on observing and diagnosing your network on AWS. So this is part 2, and we are going to be discussing the VPC Reachability Analyzer. Now, in the previous video where we discussed the VPC, the network analyzer, uh, we were looking at governance and visibility. So we are in this video of shifting from that governance and visibility to more hands-on or troubleshooting. So we'll be taking a look at the VPC Reachability Analyzer, a tool that helps us understand why something can or cannot connect inside an AWS network. So just an overview of how this differs from the previous one. In the previous video, we basically answered what network paths exist, who could access what. Now we are answering why is this specific connection failing or succeeding. So this tool is ideal when an application basically says I can't connect. So when you get, I can't connect to the database, I can't connect to what? That is where the VPC Reachability Analyzer comes in. Now, the Reachability Analyzer doesn't send any real packets, okay? It's just going to simulate a packet and then check every network component along the way. These network components, the routes, it's going to check the routes, like the routes, the firewalls, the security groups, the network access control list, all this. So it checks connectivity between the source and the destination and produces whether it's reachable or not reachable, what exactly is blocking it, if there is anything blocking it, and then you get a hope by hope network path in that case. If we were to think about it, without this tool, troubleshooting would always mean checking everything manually. But here, the reachability analyzer is basically going to tell you exactly where the problem is. So some questions which the reachability analyzer can answer. Why can't my app reach my database? Is my route table wrong? Is my security group blocking traffic? Is there any firewall denying the connection in that case? And if you take a look at the mental model of this, it's going to follow the shortest valid path and explains every decision which was made along the way. So if a packet leaves point A, does it successfully reach point B? And as I mentioned, these are just some of the things it's going to evaluate: the route tables, security groups, access control lists, the transit gateway routes, firewalls, load balance, among others. So enough talking. I think it's pretty self-explanatory, so we can go into the hands-on exercise. So in our hands-on exercise, we'll do different parts of this. But before we get started, we have to set up our architecture. Don't be alarmed. So this is the architecture we are basically going to deal with. And I have this cloud formation template that is a mirror of the architecture diagram that I have shown you. So this cloud formation template, it's not really the best because we have basically had coded some values, which basically means this template is going to work in the US East 1 region. We could do better, yeah, and make it more dynamic, okay? But just for the demo purposes, I mean, yeah, you can forgive me for that. And I'll share a link on where to get this template. It's just part of a AWS Workshop Studio. So it has a lot of parameters and lots of resources, which are basically this. So what I'm going to do is use CloudFormation to launch this template. And while it launches, I'm going to come back and try explain this architecture just to save on time over here. Okay, so CloudFormation, where are you? Okay, so let's create a stack with new resources. I'm going to choose an existing template, which is downloaded, and I'll share the link on the description. Okay. Okay, stack details, Kira, network stack. I think that's cool. And the parameters, so availability zone 1A, 1B, the instance type for our web server. We'll see all this in a moment. And I think I don't need anything much. I acknowledge that CloudFormation is going to create some resources for me. Next, and submit. Okay, so while the CloudFormation template is creating our resources, which will take some time, let's just have an overview of some of the resources that you're trying to create in this case. So if we start this architecture, the big picture of what this architecture is doing. So as you can see, this architecture is using multiple VPCs. We have the production VPC. Maybe I need to change the color of the pen. So we have the production VPC, inspection VPC, central egress, and dev VPC. All these VPCs are connected together by the AWS Transit Gateway to just enforce some strong network security control. The main idea over here is our workloads live in separate VPCs. All traffic is centrally inspected from the inspection VPC, and internet access is tightly controlled from this architecture. Nothing talks directly to the internet unless it's explicitly allowed and inspected in this case. So diving in a little bit deeper, we can see on our left side, we do have the production VPC over here and the development VPC. These VPCs contain our application workloads, each VPC. So we can see we have some EC2 instances in this case. What you can realize is these VPCs do not have an internet gateway. So these are private subnets only. Both VPCs send all non-local traffic. So you can see the route tables. Non-local traffic, you're saying do not send to the internet gateway, but to the transit gateway. And that means that the development and production environment are isolated. They don't have direct internet access, and there is no accidental cross-environment communication in that case. Now, moving on to the transit gateway at the center. So the transit gateway is the traffic director in this case. It sits in the middle and connects all the 4 VPCs in this case. And it's using different route tables. You can see each VPC has its own route table, which control how the VPCs can talk to each other, where the traffic is sent next, which paths are allowed, which paths are blocked in that case. So this is where the network segmentation happens. For example, as you can see, from these route tables, all the non-local traffic is being sent to the transit gateway. But then, again from here, for the prod and the dev route tables, all non-local traffic after coming here is basically redirected for inspection within the inspection VPC. So that is basically it, and more rules again. For the inspection VPC, on the top right, as we can see, all traffic is going to pass through here before going anywhere else. What we can see over here, we have this firewall endpoint. So the inspection VPC actually contains the network firewall, AWS network firewall. It has some firewall endpoints and also a transit gateway attachment. Any traffic that leaves production or dev, goes to the internet or process environment must pass through this firewall first. And what we're trying to ensure in this case is we do have some centralized security policy enforcement, no firewalls bypass any paths, and there is consistent inspection for all traffic going through our environment. And the other VPC over here, we have the central egress VPC. And what you can notice over here is, well, that internet gateway somewhere. NAT. Okay, so here in our routes, maybe it's, oh, here. Oh God, why would I not see that? So the internet gateway is here. So from what you can realize is, this is the only place where internet access exists. So it's the only VPC with a NAT gateway. And we know the purpose of the NAT gateway being enabling, by textbook definition, enabling our resources in the private subnets to access the internet. And the NAT gateway only allows egress, traffic. So no traffic can be literally initiated from the internet. So we do see this is the only VPC with the NAT gateway and the internet gateway performing network address translation. So all outbound internet traffic comes from prod or dev VPC. They first go through, you can see the path, they first go through the inspection VPC, they go through the firewall, they reach the NAT gateway and exit via the internet gateway. So yeah, this design prevents direct internet access, makes outbound traffic observable, and also simplifies some sort of auditing in this case. Now, let's take a look at our CloudFormation stack and see if our resources are ready. Cool. Too much talking. Great. Complete. And yeah, we have a couple of resources being created over here. We can see some security groups, the internet gateway attachments, the subnets for the central egress, the dev resources. We have the transit gateway resources and associations being created, the inspection firewall resources as well. We had some databases in the prod environment. Yeah, and so on. So these are the resources that are part of our architecture. So let's go ahead and test this, see how it works hands-on. The first part of this hands-on exercise represents a very common real-world problem. My application cannot communicate or cannot reach the database. So instead of, guessing, we can go ahead and use the reachability analyzer to probe what's blocking the connection. So in our architecture, this is going to be currently broken. And the important thing here is not that it's blocked, we want to get the exact blocking resource, where and why the connection is blocked. Majority of the time it's just, missing configuration, okay? Maybe a missing rule, or we have blocked a specific, we just have an incorrect port in that case. So with the reachability analyzer, we're going to get reachability analyzer, we're going to get a visual path, sorry. Yep. So we are going to get visibility, a visual path, which removes this ambiguity where we don't know exactly where the packet stopped. So we're going to see the full path from the source, the subnets, the gateways, any security controls to the destination, and get exactly where was the failure point in our architecture. Okay, so let's go and do the hands-on aspect of this. Okay, so let's go ahead and do the hands-on aspect of this. Yeah, so first we have some prerequisites. We just need to find the network interface ID for the database server. So I'm going to go directly to EC2. And then under here, we can see the network interfaces somewhere here under network and security. And then let me search the one related to RDS. And here it is. So yeah, it's more of a database, RDS network interface. Okay, so what I need is the network interface ID. And I can just put it somewhere. Cool. So, okay, that was it. That was what I needed. And now I can go ahead. So this is still under the network manager section of the VPC. So how you get that again, under VPC, when you scroll to the very bottom, we have the network manager. Click that link and it will take you to this specific page again. So under network manager, now we are not interested in this, but under monitoring and troubleshooting, the reachability analyzer. And now we can create and analyze path. The name tag, we can say we're trying to connect your EC2 RDS. The path source in this case, source type is instances. The source is the production instance. And then the destination is the database interface. So the network interface, and yeah, that one I pasted somewhere. And then the destination port, So destination port, just want to put it there. So for the Postgres SQL database, yeah. And then that's it. Create and analyze the path. Okay, so as you can see, we are getting a not reachable under the reachability status. Now, basically, you can scroll down to the explanation, and then under the details, okay, so under the details, you can view like detailed information about the component and the combination of components, or the combination of components which are basically blocking this path. So for example, over here, we have the security group shown available. So we can see the problem, the ENI security group rules mismatch. So it does not have an inbound rule that allows the traffic to reach the destination. And you can see all the information available over here. So none of the egress rules in the following security groups apply. You can go ahead and fix the issue based on what you are given over here. And we have been given the link to the security group in question. So here it is. And then we can just edit some roles. So outbound roles, edit outbound. And now we can add a role. And we say this is custom TCP. Okay. Port range, Postgres. And the destination IP address is the CIDR block of our VPC 10.1.0.0/16. It looks good. Save roles. We can go ahead back. So it was and not reachable, and then we can rerun the analysis. So we have a pending. Now it's reachable. So yeah, we have learned how to create an analysis with the VPC Reachability Analyzer just to identify connectivity, just to identify connectivity issue between two AWS resources. Okay, so the next part of this, part 2. So here we are trying to focus on egress traffic, which is often, tightly controlled in secure environments. So we are testing our production EC2 instance outbound internet access, and if the traffic is going to flow through the network firewall. So this tool, here we are just trying to confirm if our firewall is doing exactly what it was designed to do in that case. So the network firewall should block the traffic and so on. And instead, our security value that you're getting with the VPC Reachability Analyzer, instead of just saying this firewall is blocking something, you can say this specific rule, this specific rule is blocking our specific flow. So we're just trying to reduce any guesswork, any finger pointing in that case. So let's go ahead and try that. So, okay. So create an analyzer path. So EC2, yeah, public IP via the AWS network firewall. The source type is instance and the source is production instance. And then the destination type, you can just say an IP address, then put an IP address 55. Yeah, this one we had before. And then just some additional configuration, which is optional. We can just say the destination port 443. And then we analyze this path. Okay, so we can see the destination is not reachable, and we can get more information on why is it not reachable. So we have all the details over there. So let's check the details. And you can see that traffic is blocked by a matching firewall rule in that case. So we can see the explanation called firewall rules restriction. So basically there is a restriction on our network firewall that prevents that specific path. And when you go to the bottom, we basically see this very big path. So here at the firewall, the AWS network firewall, we can see information about the rules, and we are saying like drop any TCP traffic to these sources for this source port and this destination ports. So this traffic, our traffic is blocked because they found a matching rule in our firewall. So we can go ahead and fix the issue in that case. So we can go and check at this firewall rule. Takes us directly to back to VPC under our network firewall, as you can see. So we have the firewall and we have some firewall policies. So this is the exact rule. So we can go ahead, action, and then I want to edit, okay, the rule itself. Yeah. So this is the rule right now. So I can edit that rule. And then instead of, okay, edit. And instead of dropping, I can just say alert when the packet matches the rule because it was being dropped before. Save, I save the rule group. Says, okay, let me just check if it's updated. Yeah, now the action is alert. And now I can go back and run analysis again. And yay, now it's reachable. So after editing that. So that is exactly how the reachability analyzer works. And as you can see, this tool is most useful when something should work, okay? Something should work but doesn't. Should work. But doesn't. And you need answers fast. Where is the problem? So things like connectivity issues, troubleshooting our firewalls, validating our route tables, debugging our transit gateway, and so on. So on this together, the network access analyzer and visibility analyzer, reachability analyzer, sorry, they give you visibility, okay? Confidence gives you faster troubleshooting. Troubleshooting becomes very fast and we get a stronger network security. So reachability analyzer explains why, identify the exact blocking component, gives you a visual path as you saw, and it actually complements the network access analyzer. So that's it for this. I hope you learned something. And in the next video, part 3, we just a short video on the network manager and see how the network manager works. Thank you for watching. See you in the next one.